Greetings. Welcome to the video where I'll be showing you how to use the solution map to solve questions related to cumulative frequency distribution. So the first thing that you do when you find a question that is asking you knowledge of the cumulative frequency distribution, you look at the type of data that is presented to you. Is it a continuous data or a discrete data? So if it's a continuous data, you look whether you are given the cumulative frequency graph or the cumulative frequency table. Also, you might be given a Bosc and whisker plot or the histogram. Now let's go to the discrete type of data. So on the discrete type of data, you may be given a bar graph or a cumulative frequency table to fill. So, but on the discrete data, if you're given the cumulative frequency table, the data there might be grouped. There's a good chance that the data is going to be grouped, or also for the bar graph. Sometimes it's not grouped, sometimes it's grouped. So let's continue looking down here. We can see the arrows connecting us on this table. So here, this means that given n, you might be asked any of this information here that I just talked about, and you may also be asked to calculate the mean of the data. So the mean basically is the average. So to calculate the mean, you find the sum of all the numbers in the given list, and then you divide the sum of those numbers by the number of numbers on the list. That sounds confusing, which is why I have an example here. So to calculate the mean of this number, we'll have to add 1 and 2 and 4, 5, 12 and 7 together. Once we find the sum of these numbers in this list, and then we divide that sum by 1, 2, 3, 4, 5, 6. So we divide that sum by 6 because we have 6 numbers on the list. So that's how you find the mean. Now coming to the mode. So the mode is the number that has the highest frequency on the given list. So it's the number that appears most on the list. So for example, we're given this list 1, 2, 4, 7, 12, 7. So the mode of this list is going to be 7 because 7 appears twice and all of these numbers, they appear once. Now we come to the median. The median is the middle value in the list of numbers arranged from the smallest number to the biggest number. So they're arranged basically in increasing order. For instance, given this list here, the list on the median example is the same as the list on the mean explanation. So we can see that the median, the numbers on this list here, they're not arranged according to order. They're not arranged in order. But here on the median side, I've arranged them in order. Now we know that 1 is the smallest, followed by 2, 4, 5, 7, 12 is the biggest number. Now to find the median, we look here and we see that these numbers, they're even because they're 1, 2, 3, 4, 5. We have 6 numbers, so it's hard for us to select the median. So what you do, we take the third value and the fourth value, we add them together because the median lies between 4 and 5 right here, and you find that the median is 4.5. However, if the numbers on the list were not even, as shown in this example here, we can easily pick up the median, which is 4. 4 is the number that's on the middle of the list when the numbers in the list are arranged in order. So the median there is 4. Now let's come to the interquartile range. Interquartile range are very tricky. You need to pay special attention to them. So to find the interquartile range, first you have to find the lower quartile. To find the lower quartile, you multiply the total numbers on the list by a quarter, which is the same as dividing those numbers by a quarter. Also, you need the upper quartile. To calculate the upper quartile, you find you multiply the total number on the list by 3/4. That is by 3/4. And then once you've calculated the lower quartile and the upper quartile, you then find the difference between the two to find the interquartile range, which will be Q3 minus Q1. To have more understanding of this solution map, I'm going to do more examples so that we can see how useful our solution map is. Thank you for watching.